Hello, my name's Mr. Angus Wangus, and I have an Leedskalnin addiction. Admitting it is the first step to recovery. I just want to make a video talking about basically what I've done so far, what I've found in my experiments with Leedskalnin's Perpetual Motion Holder. For anyone who doesn't know, Leedskalnin is a guy who, in the 50s I think it was, built a place called Coral Castle out of huge rocks. He moved big rocks. One was 30 tons, and he didn't have any machinery to do it, and was very kind of like a hermit guy. So he didn't have a whole lot of help, but no one knows how he did it. And he had a generator too up in his little castle that people like to speculate about. I myself anyways, I've been thinking about it for like 3 or 4 years now. But for the last 6 months I've been testing his Perpetual Motion Holder as a generator. Now Ed wrote he wrote a number of books, and in one of his books he detailed his Perpetual Motion Holder, and this is a picture of it right here, and he told how to make it, and he told us how it operated and why it operated the way it did, right? Which is an explanation that goes against physics. And we'll talk about that, electromagnets, and what we're taught in school about magnetic field lines and the force and the direction of the force or flow. But basically Ed described that, now this is a coil on his Electromagnet PMH, and when you put electricity into the coil through these terminals, they become a magnet, right? An electromagnet. So one end is going to become north and one end is going to become south, and he told us to situate them this way. They're basically in magnetic series. And we've replicated this in the past. I have, others have. You can leave this keeper on here indefinitely, and we're going to have a look at all that. But basically, Ed said that there's 2 streams of magnetic force, one coming out of the north end of the magnet and one coming out of the south end of the magnet, and that they flow against one another in the iron and in the magnet, actually. So now what I want to show is a normal electromagnet, or a conventional type electromagnet, like this picture right here. Basically a coil of wire wound on a piece of iron, and you put a current, a DC current through that coil, and it makes a magnetic field around the coil, and it picks up other iron. And then when you disconnect the electricity, the magnetism goes away and it drops the iron, right? So you need that electricity flowing to have it be an electromagnet. Leedskalnin's PMH, and that's short for Perpetual Motion Holder, if you want to look it up, is a U, and he has 2 coils. Now you can do this with 1 coil. You don't have to have 2. Lots of people have done that in the past. Made videos of it and showed. But with Ed's electromagnet setup, you just pulse a little bit of electricity into those coils and it picks up the iron, and then it's going to keep it attached to this electromagnet. And it has to do with the 2 flows of magnetism flowing within this iron, and we're going to talk about that. That's why I want to make the video showing that. Showing a bunch of stuff. But so with this conventional type electromagnet, you need the electricity flowing in the coil to have it work as an electromagnet. Ed's, you can just tap a little bit of electricity into these coils from a battery, and this remains stuck until you pull it off. And I'm going to demonstrate that. I'm going to demonstrate a PMH in this video. So we'll see that. Now, conventional thinking about magnetism, we have, this is a magnet representation, a north end and a south pole, north pole and a south pole. And in school, like if you go to school to learn that, you pay for your course and you go to learn and you have an introductory course or a unit beginning on magnetism, this is what they're going to show you. This is what you pay to see, is these force lines coming out of the north end and the arrows pointing out and going to the south pole, and the arrows pointing towards the south pole. So the way school would teach you is that there's force going one way, right, and it's also looping this way, right? But Ed's description, sorry about that. Sorry about the poor picture here, but I tried to replicate it. North and south ends, and what Ed said is that out of the north end of the magnet we have the flow of magnetism coming out, and from the south end we have another flow of magnetism, the opposite, right? And they flow against one another. And that's how Ed described it. Now, I have a tripod now. Woo! Excuse me. So, Ed is describing two flows of magnetism, one coming out of each end of the magnet. Conventional wisdom would tell us there's only one direction of flow, right? So, with the symbols, these are symbols from the front of Ed's books. We have the Perpetual Motion Holder. We have this symbol, which I believe represents the eddy currents flowing in the iron, right? The magnetism, the two flows of magnetism coming out as eddy currents in the iron. And they flow one against the other, and he's showing that. You have two distinct flows of magnetism, or eddy currents. That's what he's showing, in my opinion. Now here's another symbol from another one of his books. It's a Yin-Yang type symbol, and it has these two two triangles, and these are the two flows of magnetism. And the way I kind of look at this one, my mind thinks about it, is this represents the core, right? Kind of like if you took a cross-section of the core and could see the magnetism in the core, this yin-yang kind of shows that. I think the same thing goes on in electrical wire too. So, but that's how I think of it. But these are the symbols that he had on his books, and they were all there for a reason, right? And he wrote the books and gave us specific explanations too. So his reasoning for his PMH, the reason it operates the way it does, and you don't need a continuous flow of electricity, is that these two flows of magnetism are flowing against one another and maintains that magnetic attraction there. So now with this video, what I'm hoping to show, I have a PMH made up and two coils. I wound these last night. I want to use the thickest gauge wire I had, and the two coils that I have of that are wound in opposite directions. I wanted to do this as Ed said. These coils are wound in the same direction. Now again, I've explored these things in my testing and videos that I've made, but I made so many of them. I wanted to kind of consolidate what I found. But I want to start out by showing a demonstration of the PMH. It's PMH as an electromagnet. Then I want to show a demo of the PMH with the coils on it next to my wheel here, right? And set it up just like I did in the past, right, in past videos, and show that, and show the positive reaction that we get. Then I'm going to show these are going to be quick demos and I'm going to edit them together. Then I'm going to show something interesting with a microwave oven transformer primary winding, and I'm just going to slide it on the end of that PMH and we're going to see what happens when we short it out. Then I'm going to demo, I don't know if you can see here, but this is a single piece of rebar, just like the rebar I used to make the PMH. And we're going to put that next to the wheel on one side of the magnet with both of these coils on it, still wired and oriented magnetically the same way as on the PMH, but I'm going to put them on that single piece of rebar, and we'll see the reaction there. And a big reason why I wanted to wind these coils, they're a little smaller, and what I want to show is that the reaction we get with Ed's Electromagnet PMH and the reaction we get with the PMH as a generator, these two special reactions are, you know, one and the same. One is doing the work and one is picking up energy, like working as a generator. But I wanted to be sure that there wasn't any speculation about this being related to ethane-Hines or capacitive reactance, delayed lens effect. They're all the same, those words, as I understand them. But they have to do with frequency and impedance, and I wanted these coils to be small enough to show that it's not an impedance frequency factor kicking in with the capacitive reactance, as I understand that. So I'm going to demo those things and then come back with a clip just talking about recap and conclusions and what all of this shows in my mind, and to show you. And so with the vid, I hope to relate the special nature of the PMH as an electromagnet and as a generator, right? And hopefully talk more about the opposing eddy currents, these two mirrored image eddy currents that work together in that iron, I think, and that's maybe what gives us the special effects. That's what Ed said. And so now I'm going to make these series of demos and edit them together, and hopefully this doesn't go on too long. If it does, I apologize, but I have a lot to say, so I'm going to try and zip through it. So there we go, quick intro, and we'll get her going. And no hands. Got my tripod. Woohoo! Okay, enough yickety yaks. Here we go with the demos. I'll be right back. Okay, I'm back. I have the PMH set up. Basically, the coils, like I showed them to you, both of these coils are wound in a counterclockwise direction. The winding doesn't matter, guys, but let me finish. They're wound in a counterclockwise, they're both wound counterclockwise, and this is the start of this winding. This is the start of this winding. This is the finish of this winding. This is the start of this winding. This is the finish of this winding, right? So the flows are going to flow one against the other, right? They're in magnetic series, is what I'm trying to say, I guess. So what I want to do is demonstrate the PMH. And again, they're wired parallel, right? And I have just two wires coming off the ends. But what I'm going to do is tap these wires onto this battery. Just tap. I'm going to hook one up to the negative. Then I'm just going to tap on the positive. Then I'm going to unhook them both, and you'll see the magnetic interaction. And again, this has been demonstrated on YouTube before. I just want to show it because I want to show everything. So here we go. There's my negative. Now there's a little bit of attraction here to begin with because I've been working with it, but it's not enough. There's remnant in that core because I've been doing it over and over. It's really very fun to think about and watch, guys. So anyways, that won't lift that bar. So what I'm going to do is hold it right here, and the negative is hooked up already, and I'm just going to tap that positive on there. Oh, didn't have it lined up. Oh, sorry about that. Here we go. There we go. Now we're flush. So now the wires are disconnected, right? There's no electricity flowing through these coils, and there's magnetism flowing in this iron core. Move the battery away. Now there's quite a force there. This is going to pick up these coils. I can shake them around. That's going to be able to hold a few pounds, a couple pounds anyway. But now Ed's description in his book Magnetic Current, he described, now we can short these, we can short them together, rub them together, right? And there's still no change there, right? And you remember it wouldn't pick it up before. So now in Ed's book he describes you can put a light bulb in here or a resistor of some sort to do work. He said to use a light bulb, and then when you pull this keeper off quickly, that light bulb will light up momentarily. And what happens is the magnetism gets released out of the core, stimulates the coil, and makes the bulb flash, right? So now there's a little bit of remnant magnetization there again, but again it won't pick up this bar. So the effect is gone now that we've pulled the keeper off, right? And again, this has been demonstrated before in the past, and by many people, including myself, others too. And that magnetism will stay once you tap the electricity and you get that to stick on there. The magnetism will stay in that loop indefinitely, Ed said. And there have been people in the past that have made these and let them sit for a long time and then tested it, right? And sure enough, that's what they found. So there you go. There's your Perpetual Motion Holder electromagnet demonstration. And next I want to demonstrate the PMH as a generator demo with these two coils on it, just like that. I'm just going to put it up next to the wheel over here and do basically what I've been doing in my tests for the last 6 months, and I will show the effect there, and then we'll move on to the next demo. Alright, we'll be right back. Okay, back. And now what I want to show, this is an open circuit, is the coils on the PMH, and show the reaction. I've done this with my videos a bunch of times previously, but I want to consolidate the ideas. Now first, the little motor here driving the wheel, I'm not going to monitor the input to that, and not monitoring the output, because I just want to show the effects, right? Now to start off with, I hope I can show this okay. The wheel's going approximately 525 RPM. I hope that's showing up on the camera. 525, right? And I'm going to be leaving the input the same for all of these demos. I'm not going to touch the input to the motor. So we're at 525. Now I'm going to short the coils. I've shorted them here together, and try and do this again. And it's speeding up. I hope you can see that. The RPM. 542. 543. So it was at 525. Now we're speeding up. We're having a good reaction, right? The energy is shorted out, basically, the ultimate load, and the wheel is speeding up. And it's about 550 right now. So there we go. That's what I've been testing and making videos of for the last 6 months. But I wanted to show it. Now we had a good reaction with the PMH as a electromagnet. As Ed describes in his book, Magnetic Current. It's a very special thing where it works as an electromagnet without just a tiny bit of electricity to begin with. And it's due to the opposite eddy currents, I'm sure, from the magnetism flowing together in the core. So there we go. And this is what I think this reaction is due to. The wheel speeding up, we're using the electricity, the wheel has sped up, and I think that the reason is the same. I'm trying to show that with not a high impedance. This is 14 gauge. I measured it. It's between 1.1 and it's less than 1.5 millimeters. Somewhere around 1.2 millimeters in there, 1.2 and a half. But there you go. And again, this simple setup I made to show these effects. It's not as big and ideal as the things I've been testing and making videos of. So there you go. We're going to go to the next demo, which is going to be the PMH generator demo with a microwave oven primary from a microwave oven transformer. And what I'm going to do is I'm going to slide that on the end of the PMH and we're going to see what happens. So here we go. I'll be right back. Okay, so finally I want to show the, just to mention, I couldn't I couldn't get this to fit properly around the back, so we're going to skip that microwave oven transformer thing. It wasn't important. I just wanted to kind of make a point that winding direction isn't crucial, and it's only crucial in the sense that you align your poles of your two coils properly, and that's a whole nother video. But just know that I started out investigating the PMH, and I originally had the coils wound in opposite directions and tested all that, and find out that's all it does is changes the polarity of the coil, and in relation to the other, in relation to how it was before, right? You wound it the other way around. What's going on here is in the iron, right? And the more pure iron you have, I'm thinking the better. So now what I have is a single piece of rebar, just like the rebar I used for the PMH, right? Same stuff. And I've put both coils on it. Now they're magnetically in series again. This is the start of this coil winding, and then the end, and then the start of this coil winding, and the end. So they're in series magnetically. I have the two wires coming together up here. It's an open circuit right now. They're not connected. And I'm going to get the wheel going. Should have done this a minute ago, I guess. Yikes. Little rub on the stand. Or is it on the wire? It's on the wire. We've seen that before, eh? Where someone had their magnet hitting the wood. Oh, jeez, I just remembered that. How priceless. There you go. Now, we're going to see the wheel goes faster to begin with. I'm trying to line it up straight. It's going to go faster to begin with. because there isn't the attraction through the core. And I'm going to let it settle. Make sure these aren't touching. There we go. So what I'm going to show is this rebar is basically on one side of the magnet passing by. They're alternating. 637, 638, 637, 630, 638, 639. So this core is interacting with one side of the magnet, not both, right? Like the PMH, there's not as much attraction, so the wheel's going a little faster, right? But what I'm going to do now is short the coils, and I used both coils together so that we would have the same impedance value, so we can distinguish perhaps between a delayed lens effect or a capacitive reactance reaction compared to what I'm seeing and what Ed talked about is being a reaction between the two mirrored eddy currents. So what we're going to do is we'll short this out. Sparky sparks. And we're going to look at the RPMs. You may be able to hear it slowing, right? Now, there's lens going on, the lens effect. What's happening is the magnetism in this core, communicating with one side of the magnet, is passing in this core and stimulating the coils. Now that they're shorted, they're creating their own magnetic field, which is counteracting the magnetic field of the magnet on the wheel, and it's slowing the wheel down. Right? Lens effect. That's normal. That's normally what should happen. I'm going to turn this off. Slow her down. And I just want to recap what we've done. So finally, what I've been trying to show here is that, and in using these smaller coils, right, with the very, very thick windings, and the wheel's only going 500 RPMs, 600 RPM. So and we had a lens reaction with both coils on a single bar, right, in more of a conventional setup, right, just the single bar caused lens. We just saw that in this last demo, right? But then when we put them on the U core with the iron interacting with both sides of the magnet, letting both streams flow through the iron, one against the other, then when I shorted the coils, the wheel sped up, right? Now, just to say again that Ed's explanation was that you have one stream of magnetism coming out of the north end of the coil, the opposite mirrored image stream coming out of the south end of the coil, and they interact in this iron together. And that's what I think we're seeing there. And that, I think that's why it sped up when we used the U-core and slowed down with the single bar, right? Communicating with one side of the magnet. Now my setup here was, less than ideal. I've had much better setups in my videos in the past. Again, I wanted to use these smaller coils wound in the same direction with the largest wire I have, really, magnet wire, so that we could distinguish what's going on, right, and rule out a delayed lens Thane-Hines or capacitive reactance type reaction. And I think I did that. Or I hope I showed that. That's my whole goal in making this video. So the opposing eddy currents flowing in both directions in the core, I believe, is what's causing this beneficial reaction. And I wanted to make this video to show you guys what I've been thinking, kind of consolidate my thoughts, show it in a way that we could rule out that delayed lens, right? I think we did that, and something special is going on. Now we already know that we have something special going on with the PMH arranged as an electromagnet, right? There have been videos made of this. Basically, it's a flux capacitor. It stores the flux, right? And can be used later when you pull that off. But we know that that's been studied, talked about, lots of videos made about that. You can search for those, right? But I'm hoping that the tests I've been doing for the last 6 months, I hope this video kind of consolidates the point of view that that same reasoning for this PMH electromagnet is the same reasoning for the good effect we get from the wheel when using it as a generator. And I think it's due to these two mirror imaged eddy currents going on in the core. I want to get some soft iron and explore that further. I've got other ideas inside. This took me 2 days to make this video, guys. I know it might not seem like it, but did it once, did it again, and because it was dark last night, it didn't turn out really well. But anyways, here I am today doing it again. But I wanted to show you, and I wanted to show you in a way to distinguish this effect from anything else that it could be. I hope I did that. I'm hoping to be able to talk about what I've been thinking better with people. I've kind of got to the point where I felt like I needed to make a consolidation type video so that we could all get closer to the same page. And if you guys see something, let me know. You know, I'm learning. I don't know everything. Jeez, no way. But I'm going to continue working with this and testing. I have other ideas in doing and setting up these videos, these demos. I had other ideas from before getting into that toroid idea that I wanted to do. And I'm going to be working on these things. I have a bigger piece of iron that I'm going to bend and try that as well. So there you go. Wanted to share that with you. And see what you guys think. And I hope I showed it in a way that that distinguishes this effect from the others. And I wouldn't label my name onto this effect. I never have anything like that. I would call this the PMH effect, or the Ed effect, or something like that. But anyways, there you go. Let me know what you think, and I'll talk to you later. Thanks for watching. See you, Ed.